Take a day break from the proofs, and we're going to go back to a triangle we talked about on day one, which is the isosceles triangle. What do you remember about it? If a triangle is isosceles, what do you remember? It has two equal sides. Well, there's a lot more to it now, and that's what we're going to talk about today, more than just two equal sides. So right off the bat here, yes, it has two equal sides, but it also has two equal angles. Okay, every isosceles triangle has two equal sides and two equal angles. I need you to be able to locate where those two angles are in the triangle. You look at where the sides are congruent and you look opposite them. Okay? So every isosceles triangle has two congruent sides. In this case here, AB is equal to AC. Where are the two congruent angles located I've been talking about? Across from those congruent sides. So in my diagram right here, yeah, AB is equal to AC. That's what makes it isosceles. But also, angle B is congruent to angle C, because they are the angles across from the congruent sides. This is a bad habit you're going to get into, and I want to eliminate it now. You always think that it's the two bottom angles. No. It all depends on where the congruent sides are. Take a look at this triangle up here. Is this triangle still isosceles? Yeah, it's got two congruent sides, but the two bottom angles aren't the ones that are congruent. Name where the two congruent angles should be in this diagram. If these are my congruent sides in the isosceles triangle, where are my congruent angles now? What two angles up here are going to be the congruent ones? Again, a lot of calling on people today. Let's start. Vinny, where are my congruent angles? Angle X and Y. So please just don't assume it's the bottom two. You have to look across from the congruent sides. Next up is the reverse, which is, all right, if the angles are congruent, so in this case, angle B is congruent to angle C, still isosceles, and where are the congruent sides now? Still across. All right, so in this diagram, we could say, because B and C are equal, so are side AB and side AC. Okay, and I'm not done here with this page. So if the sides are equal, angles across. If the angles are equal, sides across are equal. I want to make one thing clear here. This, what I just showed you, only happens in a single triangle only, not two different ones. Watch. A lot of students will start using this way, which is not the way to use it. Okay, everyone see I have two separate triangles. Let's say AB is congruent to DE. Does that mean the two angles across from them are equal? No, it does not. That's not how this works. Your two congruent sides have to be in the same triangle. Okay, it doesn't work if the two sides are in different triangles. The two congruent sides or angles have to be in the same triangle. See how this works? All right, next thing. We have to start using some vocabulary with each other because I don't want to say congruent sides, congruent angles anymore. They actually have names. So let's talk about those names. The angle between the congruent sides. So basically the non-congruent angle. Right, the non-congruent angle. The angle in between the congruent sides. Name that angle in my diagram, please, first. What angle am I referring to before I give you the name of it? Bryson, what angle am I talking about? The angle in between the congruent sides. Angle A. That is called the vertex angle of an isosceles triangle. Vertex angle. It's the angle in between the congruent sides. Or the non-congruent angle. The angle that's not congruent to the other. All right, how about the congruent sides? The two sides in an isosceles triangle that are congruent? Legs. Okay? Legs. The congruent sides are called the legs. The outcast side, the unequal side, the base. And again, you guys got to get out of the middle school mentality. Does base necessarily equal bottom? No. No, it does not. If I do this, here's the base. right there. Okay, it's the non-equal side. I don't care where it is. It's the non-equal side. And then the two congruent angles, which would be what in my diagram? What are the two congruent angles up here? One, Zoli, name the two congruent angles. Where are they?
B and C.
B and C. The two congruent angles are called the base angles. And I think they're called the base angles because what's in between them? The base. Okay, and again, that doesn't mean bottom. It just means across from the congruent sides. All right, let's apply it now. Take a look at my diagram down here. I'm looking for an angle that's congruent to R first. And let me specify, don't give me angle S or angle WVS because they're already marked with arc marks. Give me a new angle that's not marked, that's congruent to R. Find an isosceles triangle that R is a part of. All right, give me a new angle that's not marked, that is congruent to R. And we'll talk about why. All right, what angle are we looking for here? Angle R, and what other angle up here that's not marked? Dylan?
Angle RVU.
RVU, good work. Angle RVU. Take a look, everyone. Dylan's using this triangle right here, which is isosceles. These two sides are congruent, so the angles opposite have to be congruent. All right, reason, the Y part. And this is what's going to go into our proof starting tomorrow, so it's good practice. In a triangle, and I'll tell you why that phrase is important here when we write, after we're done writing. In a triangle, congruent angles are across from, how do you think I'm going to end this? Congruent angles are across from congruent sides. It doesn't bother me if these two are switched. That's fine. It's still the same statement. Here's what will bother me. This needs to be in there. Why does in a triangle need to be in there? Because this fact doesn't work for a square, doesn't work for a pentagon, octagon, nothing. This only works in a triangle, that the congruent sides are across from congruent angles. RT. Side RT is congruent to, name me another side. All right, look for an isosceles triangle that contains RT. RT and name another side here. Go somebody else. 4. There we go. Test RT and everyone see that big triangle? You're correct. I'm just explaining it. How do I know that triangle is isosceles? Simon.
Angle R and angle S.
Everyone's got two congruent angles. So what's across from the congruent angles? RT and TS, congruent sides. Yep. So RT and TS. You have to use the same triangle, not two different ones. And I'm just going to keep writing the same reason here, guys. In a triangle, if you want to switch it up now, congruent sides are across from congruent angles. It's up to you, but it's not going to matter to me. You just got to have the in a triangle part. And finally, how about VW? I need a triangle, an isosceles triangle that contains VW. And VW would be congruent to VW and Zoli. SW. Everyone see the right here? Here's my isosceles triangle I'm working with now. How do I know it's isosceles? How do I know that triangle WVS is isosceles? 1, 8. Lily, how do I know that triangle is isosceles?
Because angle WVS is congruent to WSV.
It's got two congruent angles. So automatically I know the sides across are also congruent. And then here you go. In a triangle. Are there questions how I know it's isosceles or how to find the sides or angles across? Because now we're going to put numbers to them now. Okay, now we're going to put some degree measures on some of these angles. All right, let's do this. We're going to do these together. Do you see two isosceles triangles in this diagram? Everyone sees two? All right, let's look at the bottom one. Mark the two angles that are congruent then for me. Mark the two angles that are congruent. On the bottom triangle, we see it's isosceles. So not only are those two sides, but we should be marking these two angles. All right, let me talk to somebody here. Bailey, if this angle given's 55, the other base angle should also be 55. They're congruent. So that's what allows me to put 55 there. And I don't know that unless I know my isosceles triangle fact. All right, somebody get to X now for me. How do I find angle X? Let's not forget all the work we did. I don't want to know the answer. I just want to know how you get there. How do I find angle X? Tell me the process. Micaiah, how do I get to angle X?
You add 55, and you subtract 180.
There's that number I wanted to hear. Yep, 180 degrees in every triangle. Subtract the two 55s from it. And when you have that number, let me know. Dylan, angle X. 70 degrees. Good work. Okay, one down. There, that's 70. Now I got to get to angle Y. Top triangle's isosceles. Mark the angles. Okay, what angles are congruent in the top triangle now? Because I see it's isosceles because of the two congruent sides. Hopefully we're marking these two congruent. All right, how do I get there though? I probably have to use something from the triangle below. How do I get to the Y now? Here we go. Going to 6. Alyssa, how can I use any of these angles in the triangle here?
You could do the vertical.
Hey, darn right. 70, vertical 70. So I got that for me now. All right, somebody new now. How can I find Y? Explain to me. I know at least that angle 70. The other two are congruent. How am I going to find angle Y? A lot of calling on today. 2-zip. Brendan, how can I find Y now?
Take 180.
Yep.
Subtract 70, and divide by 2.
You got it. And angle Y ends up being, when you're ready, 9, Vinny? 55 degrees. Good. Questions on how we got there? All right, number 2. Do you see the isosceles triangle there? Okay, mark the congruent angles you think. Mark the angles you think are congruent. Remember, it's got to be in the same triangle as those sides. Hopefully that dashed line's not screwing with your mind. The congruent angles have to be in the same triangle as the congruent sides. All right, are we marking these two? X and this one right here next to 110. Right, it has nothing to do with the right angle. Okay, it's got to be in the same triangle as the sides. All right, tell me how we're going to get to Y now. Or actually, let's start with X. Let's start with angle X. How do we get to X? Ooh, here we go. 2-1, Lauren. How do I get to X here?
You like I did 90 or I did 110 minus 90 and then
What do I know about the 110 and that congruent angle right next to it?
is equal to like the two opposite.
These two right here.
Oh, they make 180.
Okay, so what's got to be that congruent angle?
70.
Okay, And we just said since it's isosceles, that angle's the same as angle X, right? So what's angle X now?
70.
Also 70. All right. We good? All right, how am I getting to Y now? How am I getting the angle Y? A few different ways, I guess you could get there, but your call. Your call. Go ahead, Bailey. How do I get to Y?
Add 70 and 70,
Yep.
get 140, and then subtract it from 180.
Okay, that'll get me this whole angle, right?
And then
But I need to
divide
get,
that by 2.
okay, I could cut it in half, right? So I could take the big triangle, 180 minus 70, 70 divided by 2. I could also take this triangle here. There's how many degrees in that triangle as well? 180 as well. So a couple different ways I could get there. Either way, we're still going to get what for angle Y? When you're ready with your calculation there. Lily, when you're ready. 20 degrees, good. All right, that was it for today here. Now you're going to go into your textbook and crunch some more numbers with isosceles triangles. Finish it. I want it finished before the end of the period, so there's no issues tomorrow.